Hi everyone, myself Sayed Ali,
And this is Prashant.
and we are going to present a lecture on UJT triggering circuit of SCR. First of all, what is a UJT triggering circuit? The unijunction transistor is a highly efficient switch. Its switching time is in the range of nanoseconds. Since UJT exhibits a negative resistance characteristics, it can be used as a relaxation oscillator. With UJT working in the oscillator mode, the external resistance R1, R2 are small in comparison with the internal resistance RB1, RB2 of UJT bases. The charging resistance R should be such that its load line intersects the device characteristics only in the negative resistance region.
As you see here, we have built the UJT relaxation oscillator circuit using the multisim software. Here we have used 25 volt AC supply to the bridge circuit and 1 kilo ohm resistor is connected here. Zener diode is connected across the bridge circuit to limit the voltage, and it will clip at 18 volts. And one DRB resistor, that is a variable resistor, is connected in series with the capacitor, and when SCR is connected across the circuit, the cathode of the SCR is connected to the pulse transformer, and the anode of the SCR is connected to the 1 kilo ohm.
Channel 1 of the oscilloscope is connected across the bridge rectifier circuit, which is nothing but R2, and as we see here, the output of the rectifier circuit is connected across the resistance R2, and oscilloscope channel A is connected across the rectified output, that is nothing but 250 ohm resistor. By simulating this, we will get a rectified output across the channel 1. That is, by clicking on the oscilloscope, we can observe the rectified output across the resistance R2. Let us connect a channel B across the Zener diode in order to get a clipped voltage at the level of 18 volts. Now we can see the clipped voltage at the level of 18 volts. In order to see the voltage across the capacitor, connect channel B across capacitor. Let's connect channel B across the capacitor. The waveform of capacitor charging and discharging is as shown in the graph. Now connect channel B across pulse transformer in order to view the voltage across pulses to trigger. This is the output of the 1:1 pulse transformer. Now connect channel B across SCR. This is the voltage across the SCR. There is a little distortion in the waveform because of internal characteristics of SCR.
Here we can see the waveform of UJT triggering circuit. The first one is, this first waveform is the voltage across the bridge rectifier, and this one is the voltage across the Zener diode, which clamps the voltage at 18 volts, and this voltage is the voltage across the capacitor. This is the charging voltage of the capacitor. It will charge to the peak voltage and it will discharge to the zero voltage. And here the charging rate of capacitor can be varied by using the resistor, that is variable resistor DRB, which is connected in series with the capacitor. If the resistor value is more, then the charging time of the capacitor will be more. Therefore, the alpha value is also increases. When the capacitor charges to the peak voltage, it will discharge in the opposite direction, and it discharges to the pulse transformer, and the pulse transformer, it converts this voltage to the pulses as shown in the waveform. These pulses are given to the SCR gate for triggering the SCR. The turning on of the SCR can be controlled by varying the resistor value, which increases or reduces the alpha value. The delay angle, which is also called as a firing angle, it can be varied by varying the resistance RC, which is connected in series with the capacitor, and the firing angle alpha, it can be varied from 0 to 180 degrees. The Zener voltage acts as a supply voltage for UJT relaxation oscillator. The Zener and the capacitor voltage become 0 at 0 pi, 2 pi, 3 pi, etc. The synchronization with the zero crossing is achieved, and the UJT trigger circuit can be used to trigger SCRs in single phase converters, AC regulators, etc. Now let us analyze the mathematical analysis. The peak voltage at which the UJT turns on is given as Vp is equals to eta VBB plus Vd, where Vp is the peak voltage, VBB is the supply voltage of the UJT circuit, and Vd is the forward drop of the UJT, and where eta is the intrinsic standoff ratio, and T is equals to Rc into C, natural logarithm of 1 divided by 1 minus eta. Here we know that the firing angle alpha is equals to omega into T. Alpha is also is equal to omega Rc into C, natural logarithm of 1 divided by 1 minus eta. This equation gives the firing angle of UJT triggering circuit. Here omega is nothing but 2 pi f, where f is the frequency of the UJT. The resistance R2 should be selected as follows, that is R2 is equals to 0.7 into the bracket RB2 plus RB1 divided by eta VBB. The resistors RB1 and RB2 are interbase resistance of the UJT. R2 can also be calculated as R2 is equals to 10 raised to 4 divided by eta VBB. Width of the triggering pulse T2 is equals to R1 into C. More accurately, this pulse width will be T2 is equals to R1 plus RB1 into C. If the leakage current is given, then the R1 can be calculated as VBB is equals to I leakage into the bracket R1 plus R2 plus RB1 plus RB2. The maximum value of RC can be given as R2 maximum is equals to VBB minus VP divided by I. Similarly, the minimum value of RC is given by RC minimum is equals to VBB minus VV divided by IV, where VP is the peak voltage, IP is the peak current, IV is the valley voltage, VV is the valley voltage. Thank you for watching our presentation.